Part of the show, ask your questions. Ellie Fox, I would face the front of the room because my patience is waning. Yeah. Anybody have any questions over this? Unless we will begin then with conjunction, junction, what's your function? Rachel Dixon says, how do I do 15? Once again, I suppose it's good to review that since it's going to keep coming up and you will have a test on Friday that deals with such things. Let's discuss it again. It's my hope that you look in your notes, Rachel, at some point in all of this. Because I know stuff, help thyself become such as to that. You will have you're given this, right, Rachel? Y equals negative 1/4 x plus 2. If you're still struggling with this, just listen carefully. You're supposed to find the line that is perpendicular to this and that crosses, that goes to the point 1, comma 1. Am I correct in that? Did I hit all those things right? Rachel, what do you know about lines that are perpendicular? This is where you'd have to look in your notes because I'm pretty sure I went over this multiple times. What do you know about the slope of perpendicular lines? Okay, see that, and I don't see you looking at your notes, so I'm wondering why, because, ladies and gentlemen, the reason I allow you, and you should take notes, is because you can't possibly remember all the stupid stuff in math, so you just look at your notes and it tells you exactly what you need to know about them. Zach, what do I know about perpendicular lines? Oh, boy. It flips and it's opposite. It's the negative reciprocal. So, Rachel, I know that my new line is the opposite reciprocal slope of that, which means my new line will have a slope of positive 4. Because if you flip this fraction over, the 4 is on top, 4 over 1 is 4. It's negative, so it becomes positive. What I don't know is where it crosses the y-axis. I need to find the letter B, and then my problem is over. I'm completely done with it. All I have to do is find where B is. Sam Sleezer, how do I figure out where this letter B is? The question is, why in the world would they give me a point?
So take the x point, you put it where x is, and the y where the y is.
Exactly. It's just as simple. You know that x is 1 there and y is 1 there. They give you this point so you can put these numbers in for the letter x here and in for the letter y there, and then you can just solve it for what the letter B is and put the B in there. So I know that y is 1. How do I know y is 1, Jordan Shaw? I know, it's a tough one. Jacob, maybe you can help me. How do I know that y is 1?
It says
1. Because there's a point right there. And 4 times x, which is 1. Jordan, how do I know that x is 1? Both x and y are both 1. And then what do I get? And that's plus b. So I get 1 equals 4 plus b. I solve it for b. I just subtract 4. I subtract 4. I get, Zach, that looks like your 4s. So b equals negative 3. I just put negative 3 right here, and that's the answer to my problem. Y equals 4x minus 3. Parlez-vous français? Je ne parle pas anglais. Je suis.
What?
I'm going to forge ahead unless somebody else jumps in here. You understand the factoring? Let me give you one of these factoring things again as a review. Remember, if you have x squared minus 7x plus 12, and you are asked to factor that, what are you going to do? Colton, you seem to be mesmerized by this at this point. What am I going to do, Colton? This is what we did last week on Thursday. What's 2? I'll give you the starting point. You have to figure out what 2 binomials multiplied together will give you that. The reverse of FOIL. First thing, Paige Gilman, help Colton out. What am I going to do first? It's like a no-brainer. No. The first thing you always do is, yeah, you know that there's only one way to get x squared, which won't always be the case. I just put my x at x. It has to be that because first terms multiply give me the first term. Now Paige says negative. You're not looking to factor those out. You're trying to figure out what? You are trying to figure out, you know the factors of 12. You have to figure out what times what multiplied gives you this, when added together gives you that. So you sit in your head and rumble around, how can I get 12, 1 times 12, 2 times 6, 3 times 4, but only one of those combos is going to give you a 7, which, Frankie, is?
-3 times -4.
Right. And you have to make sure, does -3 times -4 give you a positive 12? Yes. When you add them together, does it give you -7? Yes. -3, -4. Happy? If you're happy and you know it, clap your hands. All right, very good. Any other ones before I go ahead and just figure that was brand new. We'll do a lot of that. You'll do a lot of that in your mathematics world. All right, take out a blank piece of paper this time. I don't have notes for you. You're gonna have to go old school and do it yourself. Who was the one that calibrated this?
Jacob.
No, Daddy.
Jacob. Like 5 times.
Wait, what did you say? Drawing those ones?
Mixing a little bit of English with mathematics here today.
Oh.
We talk about conjunctions. Jacob, make Miss Shum proud and tell me, what is a conjunction? It is. Hey!
Not just
And is one of them.
4. Oh my gosh.
In math, we have the 2 conjunctions we're going to talk about, and they are the word and the word or. Those are the 2 conjunctions that we will talk about with inequalities. An inequality, tie hop, is a? No, that's a rational number.
Go back to Jacob.
Inequality, Curly? Yes, it's those little things that tell you things that are not equal. So here's what it would look like. If I asked you, write this down, give me a number that is less than 8 and greater than 4, what would you tell me? Give me a number that is less than 8 and greater than 4. APS says 5. Ty says
6.
Ty says 6. Frankie says
5.
Oh.
7.
yeah. See that? Now, so this is the way this phrase would look like in math. Okay, give me a number that is less than 8. X has to be less than 8, and X has to be greater than 4. Right? Wasn't that what I said?
Yeah.
And. Okay. The word and means both have to be true. Okay, both have to be true. Okay, and in math, we have a short way. You can write it like this, ladies and gents. Or in math, they've kind of shortened it and it looks like this. This and this are the same thing. Okay, you just have to kind of recognize this, and when you say this out loud, you would say it just like I said there. X is greater than 4 and less than 8. With me? This is the conjunction and. These two mean the same thing. Sometimes they'll write it out like this. Sometimes they'll write it out like this, but they mean the same thing. Give me numbers that are greater than 4 and less than 8. Now, if you were to graph that, watch how easy this is. Chunk, chunk, chunk. I know I have these numbers here. So there's a dot at 4 and there's a dot at 8. The question is, are those going to be open dots or closed dots? Based on what we know already, yes. Okay, there's no equal sign here, so it starts at 4, but it doesn't include 4. And it goes to 8, but it doesn't include 8. And then you're going to color in the middle of that thing, which is what we said. X could be 5, it could be 6, it could be 7. It could be 4.2, it could be 4.9, it could be 7 point whatever. It just cannot be 8.
Wait, there was something there. Somebody said something? Who is that? Sam, did you say that?
Colin said, what did you say, Colin? Was it important? Was it importante?
Yes.
Wait, what'd you say?
It'd be 4.1415966535.
No, that's 3.14159.
We can make it 4.
654.
So let me give you another example. What if it was this? X. The graph of that would be, it's pretty simple. Here at -2, open circle or closed circle? Closed because of the equal sign there. X is greater than -2. And that goes all the way to where X is 4, which is a open circle because it can't equal 4 because there is no equal sign.
Wait, that's it? What if the symbols are the other way?
I am glad Frankie said that's it, because obviously math is not going to be that easy. Let me look at some issues here. Where did this thing go? So,
Here you go, another.
this is another one. Notice X is greater than 4. Oh, wait. Oh, wait, sorry, no, I ignore this, that's not there.
What?
This is just the same way
Who
to
was
say
the
this.
first one to do this problem?
X is greater than 1 and less is, X is -4. So here at 1, it's open, 4, it's open. I'm moving on, hold on. Now, let me rephrase this question to you. Give me a number that is less than 3 or greater than 9. Less than 3 or greater than 9. Zach, give me one of those. Give me a number that fits one of those categories. X is less than 3 or greater than 9. Wait, 4 is less than 4, Zach, is not less than 3. Give me a number, Zach. If I said that I want a number that's less than 3 or bigger than 9. 10. Yes, congratulations. Jordan?
4.
Come on, Jordan.
This is the hand I've been dealt. Tori? 2 is less than 3, yes.
I think you got
Colton?
hit by dodgeball.
11. Paige? Okay, yeah, 15. Notice what numbers can't they be?
2.
Zach?
What Jordan said.
Maybe the numbers. It can't be 4, 5, 6, 7, or 8. If it is an OR problem, ladies and gentlemen, write this in your notes. OR problems have arrows that go in opposite directions. In other words, here's my graph. Okay. I am starting at X has to be less than 3. So here at 3, it's the numbers that are smaller than 3. And here at 9, it's the numbers that are greater than 9. Okay. Any number less than 3 is my answer. Any number greater than 9 is my answer. What you don't have is the middles colored in, which is the difference between and or problems. Watch. Let's do a little looking. Let's take a look-see here.
So or is opposite and is.
Where did they go? This it? And problems come together from the dots, or problems shoot off in opposite direction from the dots. Okay? And problems have to both be true, or problems, either one of them can be true. Got that here? So here's another, for example, of that. I don't know where it is, but it's here somewhere. Anybody see it? Now, unfortunately, ladies and gentlemen, sometimes, Conrad, you're going to have to solve the inequality before you graph them. So if you look at this, which is not a big deal, if you have x minus 3 is less than -5, how do I solve that? It's like an equation, you do the opposite, you add 3, you add 3. So x has to be less than -2, or, how do I, oh, here's a complicated one. What do I do here, ladies and gents? Jordan,
You divide
by,
-2.
and what happens when you divide by negative?
So you flip the.
Look at Jordan, kids, why can't you be as excited as
Yeah.
Jordan about this? Max, why can't, even on your birthday, you be as excited? So, this goes away. This becomes its opposite. -6 divided by -2 is a +3. So saying this, x has to be less than -2 or greater than 3. What's the graph of that? At -2, it's open circle going this way. At 3, it's an open circle going this way. Now somebody say it just can't end up being that easy all the time.
Can't end up being that easy.
Yeah, because we like that easy.
I need you to look at this, ladies and gentlemen. And then I need you to say, Max, these are your words. What in the wide, wide world of sports is going on? Max, what in the wide, wide world of sports is going on? What's confusing, Max, about this?
Oh my God, Sam, are you wearing socks?
Yes.
What is up with this right here?
What does Sam wearing socks have anything to do?
What do you mean, Nathan?
Patty and Nathan? Are you kidding me, guys?
Nathan's just wearing sneakers.
Those
You're so wearing blazers.
Tennis shoes.
We're in crusty.
No.
Why are shoes so long?
Why do you care so much? They gotta wear socks.
I am wearing socks. Want me to pull them up more?
Those are
It's
not
just
socks.
I'm pulling them up just for you.
No, Sam.
I'm not talking about
quiet.
Quiet.
Are you happy
That's so
right
loud.
That's almost
That is so loud.
All right, Jacob, look up here, please. Here's the deal, ladies and gentlemen. The problem with this is it doesn't just have one little itty bitty X in the middle of it. It's got all this other garbage. Okay? Which means you've got to get rid of excess garbage because the X, you need it to end up saying, oh boy, no, please don't get any bigger. You need it to be rid of all the excess middle so it looks like X is on whatever number on the number and whatever sign there. Now, how am I going to go about doing that, you ask? Well, you think about equations. What do I have to get rid of to just get my X here? The 2 and the 7, right? How do I solve equations? I always get rid of the plusing and the minusing first. But here's the deal. You have to remember this is actually 2 equations. One where it was the greater than, one where it was the less than thing. So when you solve this, you need to do this. Yes, I have to subtract 7, but I have to do it. I have to do it to both sides. When I subtract my 7, I can't just pick or choose one side or the other. I want to get rid of it from both sides. So when I subtract my 7, this becomes a -22. This becomes a -16. Okay. And now I left with my 2x, and the same thing is true with the 2x in there. I need to get rid of the 2, so I have to divide by 2, but I need to divide all sides by 2 because there's 2 equations there technically. So when you're done, you're left with a -11, boom, boom, and -8.
Do you flip the sign? No, you didn't divide by negative.
Thank you, Jordan.
Thank you, Jordan.
And how do you say this? X, everybody repeat after me. X is greater than or equal to
Is greater than but equal to
-11.
-11.
And X
X
is less than or equal to -8. Now, a couple things. That doesn't make a lot of sense because this is the less than sign and you said it was greater than, but the alligator is eating the X. So X is actually greater than or equal to -11 and X is less than or equal to -8. Second thing is this, ladies and gentlemen. Okay, never when you have these compound inequalities will the sign be going the other direction. Why, you ask? Because this would be impossible. Because if I asked you to give me a number where x is less than negative 11, but it is greater than negative 8, there is no such thing. Huh? Well, you couldn't because it's not there. So this will always, the inequality signs will always look that way, or they should anyways. They might give you some sort of a thing. The graph of this then would be negative 11, closed in circle, negative 8, closed in circle, and it's an and problem. And problems always get colored in the middle. That is the answer to that. Woo, take a deep breath. Okay, it's just me. You don't have to. Now, what about this one? What about this one?
What about this one?
This one is an OR problem. You don't put the OR things together. So this one, you just have to solve both equations as it is. How do I get rid of the negative 3? I add 3, so x is greater than or equal to 7. Or means what's going to happen with the arrows, they're going to go off in different directions. Subtract 2, x is less than a negative 7. When I graph it, what's going to happen here? You're at positive 7, open circle goes off in this direction because it's x is greater than 7.
No, but.
You're at Jordan, you're at negative 7,
Chico.
open circle.
That was Frankie, actually. No, you have to build the circle. That was Jacob.
No. This is an OR problem,
This is an
Jacob.
OR problem.
The other one is,
Maggie.
oh, I do have to fill in the circle. Say it again, Jacob. Louder. Louder.
Jordan,
Stop correcting. Stop correcting.
You were wrong, Jordan. You were wrong.
No, wait, no, it's this one, wasn't it? Sorry.
No, it's the other one. That's the right one.
Wait, what just happened?
Jacob keeps your ass.
Violet.
This one,
One.
x is greater than is this one. X is greater than 7, or equal to 7.
World star.
Jacob.
Let me give you one for you to try, because then I'm gonna give you your homework and you're not gonna like it. Oh, I grabbed the wrong. Okay. Where did it go? Oh, here it is, sorry. I'll give you one that's actually part of your homework, and then you'll be able to say, hey, I got it.
Good job.
I don't remember.
I gotta find it. I think I left
Hey,
it.
I got the over your head.
Ready?
Andrew, actually, as well.
I'm very appreciative.
I think we have trouble here. Is that something here? Oh, it is here. Yep, right here. Write this one down because this will be part of your homework. And you're killing me.
You're killing me, Addie. I can't help myself.
Negative 35 less than or equal to negative 3x minus 11 less than or equal to 19. Do not.
Wait, is this an or?
I need help.
What word does it say?
Or and.
Neither.
Do you see the word or there?
I see nothing.
If you don't see the word or, it's going to be in. Wow. This is just page 1, by the way.
What the? I like this.
Thank you. I'll get my birthday off.
There you go. Wait, what's your birthday? That's a lot.
You already had it.
I don't.
February?
I guess we'll take
No.
Remember, this is the one where you have to solve both sides.
Did you solve it?
This is actually only the first page. There's another one?
There is another one. Don't know where it went.
Sean, can I work at your house?
You already asked me that. Submit your
Andrew,
resume.
do you think you'd be a good employee?
Yes, I want money.
I don't think you would.
Hold the full.
At least he has a
You know, you
goal.
could work at Whitetail where.
I can work at White Tails now?
No.
I'm with cat.
Where were the White Tails?
I'm with catfishing and money. Wait, Miss Shawn, I have a proposal. What if I didn't work at a stand? You gave me hot dogs and I went house to house trying to sell them.
Tyler, can I be a bartender?
Andrew, it's gonna be your favorite place to be a hot dog.
I have a basket of hot dogs and chips and a drink and I go house to house. You would take a hot dog.
This is the way this would look, ladies and gentlemen. I think it's probably, I don't remember what problem it is. Again, Gordon Shaw. Okay, this is an and problem. You need to get this down to just be an X. Just like equations, you have to get rid of this and this. The first thing you do is do the opposite of this and add 11 to both sides because it's really a combination of two equations there. This goes away. You're left with a negative 24 less than or equal to negative 3x less than or equal to 30. 11 plus 19. Then Jordan Shaw, as Jordan said before, here's where you have to recognize, Jacob, I am dividing by a negative. So what's going to happen in the end? These signs are going to change to their opposites. Negative 3, negative 3, negative 3, but these are going to go the other way. Now, before you get all bent out of shape, let's do this. This is 8, this is x, this is negative 10. Now, this is all written kind of backwards, but if you think about this revolving around the thing, the negative 10 should go over here, the 8 should go over here, and these signs would actually point this opposite direction because it did rotate around that sort of thing. X has to be greater than or equal to negative 10 and less than or equal to 8. It works out nicely. Here at negative 10 and 8, they're closed in circles. And this is colored in the middle. Yes, now Jordan, your question.
Why does
Because when you write an equality, you always put the lower number to the left and the bigger number to the right, because that's the way you would read it. X is greater than or equal to negative 10 or less than or equal to 10. Okay, so you just have to rotate this. Think about it being on the swivel as it moves around. Don't worry, we'll do this a couple days, probably at least.
How do you know if it's an and or an or?
It says,
And or.
Jacob, if it doesn't
It
say,
doesn't say or.
yeah,
It's
Jacob, this is an and because there's no word or. If you don't see the word or in it, it's going to be an and. If you don't see, no. What's that? Did you say, how do you graph it?
Ands are always.
We don't need it.
Wait, why'd you flip it?
Why would we nice to know?
Because the small number always should go to the left, because that's how you graph it. All right, you have thy worksheet there. Carry on. Let me know if you have questions. What's that? Not until you try it yourself. If there's one thing I learned about people when she doesn't like to try things.
No.
And now I get an extra paper.
I do. You need a board.
I can have one.
Which one? Both sides?
Oh, she's putting on.
Yeah, they're taking all about it.
What's your number? Frankie, what's your number? Frankie, what's your number? Frankie. What?
Frankie, will this make you happy? Oh my God.
Well, you,
Sam, your shoes are actually I really Sam, where'd you get it? Are you sure they're okay? It's a nice Sam, Sam, it's a 50% trust.
I look at Ronnie.
Sam running with
What?
Mikey was over
Very tight.
I was like, and then Frankie looks over.
There's 30 problems. Julia. Julia. I quit school. I quit school.